Double-sided PCB manufacturing process. Cutting is the initial process in PCB production. I mean to cut the large-sized copper clad board into the appropriate working size for subsequent processing. The cut boards need to be inspected for issues such as size accuracy, edge bursts, and surface scratches. Generally, the size tolerance is required to be within 0.1 毫米, and there should be no obvious chipping at the edges. Modern PCB factories use high-precision CNC drilling machines with drill heads rotating at speeds of 15,000 to 30,000 revolutions per minute, and positioning accuracy reaching 0.025 毫米. The drill hole diameters range from 0.1 mm to 6.5 毫米, and micro hole processing has become a key technology in the PCB industry. After drilling, a large amount of copper chips and resin dust will be generated. These residues need to be removed through high-pressure cleaning and ultrasonic cleaning to ensure the clean lenses of the hole walls and prepare for the subsequent plating. Plating copper is the process of depositing a thin layer of copper on the non-conductive hole walls to make the hole walls conductive and prepare for subsequent copper plating. The thickness of the plated copper layer is usually 0.3 to 0.8 micrometers, requiring uniformity and completeness without holes, cracks, etc. The coverage of the hole walls is checked through backlight testing, adding copper on the basis of plating copper. The thickness of the copper layer on the hole walls and the board surface is increased through electroplating to ensure conductivity and mechanical strength. Graphic electroplating, selective electroplating. After graphic transfer, the thickness of the copper layer after electroplating depends on the product requirements. The copper thickness in through holes generally needs to reach 18 to 25 微米 to ensure sufficient current carrying capacity and mechanical strength. The micro-slicing technology is used to inspect the uniformity, thickness, and adhesion of the copper layer on the hole walls to ensure no delamination, holes, etc. Outer layer graphics production. The process of transferring the customer's designed circuit graphics onto the copper surface of the PCB. Surface treatment. Cleaning the board surface to improve the adhesion of the photosensitive film. LD laser direct imaging. No physical film is required, and the image is directly formed through laser scanning with higher precision, suitable for fine line production. Development. Dissolving the photosensitive film in the unexposed area positive process or the exposed area negative process, exposing the copper surfaces that need to be retained or etched. Selective electroplating after development to increase the copper thickness on the hole walls and the surface and form an anti-etching protective layer, further increasing the copper layer thickness on the exposed copper circuit graphics after development to ensure the conductivity and mechanical strength as per the design requirements. Plating a layer of tin or tin lead alloy on the electroplated copper layer as a protective layer for the subsequent etching process, as it is more stable in the etching solution than copper. The thickness of the tin layer needs to be uniform and consistent, usually between 3 to 8 微米, ensuring complete coverage of the copper lines that need protection, without pinholes, underplating, etc. Removal of the unprotected copper foil to form the final circuit graphics, using acid IC copper, chloride or alkaline ammonia water etching solutions, reacting with the exposed copper to dissolve the unwanted copper layers while retaining the circuit parts protected by the tin layer. Modern PCB factories use continuous spray etching machines, which achieve uniform and controllable etching effects by precisely controlling the temperature, concentration, and spray pressure of the etching solution during the etching process. In addition to vertical corrosion, lateral corrosion also occurs, resulting in a trapezoidal cross section of the circuit. The etching factor, the ratio of copper thickness to lateral etching amount, is a key parameter for measuring etching quality, and high precision circuits require a high etching factor. Desoldering. Removing the solder layer protecting the circuit to expose the underlying copper circuit, strictly controlling the desoldering time and temperature to avoid over-corrosion that causes the circuit to become thinner or damaged. After desoldering, thorough water washing is required to avoid chemical residues. OE inspection. Using optical principles to automatically detect surface defects of PCBs. Modern OE equipment can detect defects as small as 10 微米, with a detection speed of several square meters per minute, significantly improving detection efficiency and consistency. The detection system automatically records the location and type of defects and generates a detection report, providing guidance for subsequent repairs. Maintenance. For repairable defects detected by OE, perform manual or automatic repairs. The repaired area needs to be re-inspected to ensure that the repair quality meets the requirements. Severe defects or those that cannot be repaired are disposed of as scrap. Screen printing. Solder mask. Coating an insulating protective layer on the PCB surface to prevent short circuits during soldering and provide insulation protection and moisture-proof functions. The solder mask layer is uniformly thick, typically 15到25微米. The opening positions of the pads are accurate without deviation. The solder mask layer is fully cured, with hardness adhesion and insulation meeting requirements. Text, printing information such as component markings, polarity marks, and board numbers on the solder mask layer. Curing. After printing, undergo heat air or infrared baking to make the text ink fully cured, with good adhesion, wear resistance, and chemical resistance. Heat wind leveling. Coating a layer of tin lead or lead-free solder on the solder pad surface to improve solder ability and oxidation resistance. Soldering agent application. Coating a soldering agent on the board surface to improve solder wetting. Immersion soldering. Immersing the PCB in a molten solder bath. Heat wind leveling. Using high temperature and high pressure hot air to blow the board surface, removing excess solder and making the solder pad surface flat. Cooling and cleaning. Quickly cooling and cleaning the residual soldering agent. Secondary drilling. Some PCBs need to drill positioning holes, installation holes, or special shaped holes at high precision positions. The position accuracy of secondary drilling is higher, usually using an optical positioning system with an accuracy of 0.05 毫米. Forming processing. Processing the work board into the final size required by the customer. CNC milling machine. Using carbide milling cutters to cut along the design contour with high precision, suitable for complex shapes. V-cut cutting V-shaped slots on the board surface to facilitate subsequent board splitting. The shape size meets the drawing requirements. The edge is smooth without burrs. The board surface is free of scratches. The slot hole positions are accurate. Electrical performance testing. Verifying whether the PCB circuit connectivity and insulation meet the design requirements. Flying probe testing. Using a moving probe to test point by point, suitable for small batch, high-density boards. Needle bed testing. Using a custom needle bed to test all points simultaneously. High efficiency, suitable for mass production. Impedance testing. Measuring the characteristic impedance of high-speed signal lines to ensure signal integrity. Electrical testing requires 100% coverage of all design networks to ensure no open circuits, short circuits, etc. The test program is generated based on the customer's design file and compared with the actual circuit for verification. Inspection holes. A specialized inspection process for PCB hole quality, inspection contents, hole position accuracy, plug hole quality. The inspection process involves the combined use of various technical methods, including automatic optical inspection, X-ray inspection, and microsection analysis. Visual inspection. The final manual inspection of the PCB's appearance quality is conducted to identify defects that the machine might have missed. Inspection items. Surface defects such as scratches, depressions, and contamination. Solder mask quality, color uniformity, bubbles, wrinkles, adhesion, text quality, clarity, position accuracy, pad quality, flatness, oxidation condition, form quality, edge burst, dimensional accuracy. Inspection standards. According to international standards such as IPC-A-600, defects are classified into acceptable, passable, and rejectable levels to ensure consistent quality of the shipments. Packaging and shipping. The final step is to ensure that the PCB is safely delivered to the customer. Packaging method. Vacuum packaging prevents moisture and oxidation, suitable for long-term storage. Anti-static packaging prevents damage to sensitive components due to static electricity. Separation packaging uses partitions or bags to separate each PCB, preventing scratching against each other during transportation. PCB production is a highly complex and technologically intensive manufacturing process, with each step embodying the essence of technologies from multiple fields such as materials science, precision machinery, chemical engineering, and automatic control. As electronic products continue to evolve towards miniaturization, high density, and high performance, PCB manufacturing technology is also constantly advancing. The application of advanced technologies such as high-density interconnection (HDI), any-layer interconnection, and embedded components is driving continuous innovation in the PCB industry. In the future, intelligent manufacturing, green production, and flexible manufacturing will become the main directions for the development of the PCB industry, providing a more solid foundation for the advancement of electronic information technology.